And I believe we are live. My computer says we're live, so I guess we're live. So welcome to the stream. We have a good number of people on the panel tonight. The subject for tonight's stream is material testing and methods how to test filament strength and filament properties. And we got a guest here, Stefan from CNC Kitchen. I have some questions lined up in my mind for him, and he'll do his best to answer. And if you have questions for him or any of us or George also, he has some experience on this type of men in the chat, and I will try to answer as many questions as we get. But for now, I want to go through the panel and give everybody a chance to do their introductions. So I'll just start from my left. So Kat, you're up.
Yeah, hello. My name is Katja, aka Cat3D. I'm on YouTube. I have a small little channel, and I'm talking about dozens of things. You know, testing materials, testing printers, building printers. I created a handbag that I knitted and crafted by by bits and pieces, and I'm going to make jewelry in the future. So I will print them first, the pieces, and then I will cast them, and I will show the whole workflow. And I'm going to combine them with lamp work beads. So I'm a kind of crossover girl, a little bit of everything.
Yeah, thank you, Kat. And George, you're next.
Hi, everybody. I'm George from MVO Engineering. We're a small company based out of the UK, but we've seemed to have quite a global reach lately. We've sold to every corner of the world right now, and from Latin America all the way to Asia, including China, by the way. Started in 3D printing because my brother started doing a PhD in additive manufacturing, and I was in the oil field for about 11 years prior to that. So a lot of engineering knowledge, and the 3D printing has come and has just expanded upon that. It started out as a small hobby, but we've gotten quite good at it, let's say.
Yeah, thank you. And James, you're up.
Okay, I'm James from Sonic Alchemy and Makerspace. Myself and sometimes with my kids, we do making from everything from small little tests to BB-8, full-size working BB-8. Built a couple of 3D printers, a CR10 size printer, a Thomas and Lederer's dolly design. Mine's called Smully. Otherwise, recently doing a lot of testing. So we're working on printing up some wind turbines and designing and coming up with some different things to test. Low carbon footprint, getting things off the grid. Going to try and charge all of our devices just by creating, say, wind turbine and solar powered things. And so that's kind of a range of things. Also do testing of filament and set up and testing out some. Currently testing out some the TMC 2130s. And some new guidance things, and I've just started looking into some of the 17s with the encoder. So that's a little bit about Sonic Alchemy and Makerspace on Twitter. Sonic Makerspace on Twitter, Sonic Alchemy and Makerspace on YouTube, Instagram, and all the other places. That's us. Thanks, man.
Yeah, thank you. And Stefan, you're up. Yep, there you are.
Yeah, hi everybody. I'm Stefan. I have a small YouTube channel called CNC Kitchen. I started 2 years ago. I do lots of 3D printing related things that are maybe not always the standard way. I want to show everybody what you can do with 3D printing besides of printing fidget spinners and models that you can find on Thingiverse. I'm currently working a little bit on DIY filament extruding. I usually look for projects that interest myself, where I can tinker, where maybe not a lot of information is around on the internet. And I just want to show how with an engineering approach you can make, you can use 3D printing in a way that is maybe not as common. In my normal work, I'm a research engineer, also in additive manufacturing, but a more professional way. So there is kind of a lot of influence from my professional work to my YouTube channel that I do in my spare time. And I'm really happy to join you guys here today.
Yeah, thank you, and we're happy to have you on. And Don, you're next.
Yeah, hello everybody. My name is Don. I am the German 3D printing nerd in YouTube. And of course, you can find me in Facebook as Donados57 or Don Burkholder. And in Twitter, it's Don Burkholder3. Why it's the 3, I don't know. But yeah, I'm in the printing areas, or I've been in the printing area since 2015. I've had a Wanhao i3. I've got a Wanhao D9 right now. And my main area of interest is everything having to do with sci-fi. And right now I'm building a hypercube printer. And yeah, I think that's enough for now.
Yeah, okay. Thank you. And I'm Marteinn. I have a channel called 3DP Iceland. And I do a lot of things on my channel, test filaments and products that I install on my printers, do projects on how to upgrade and do upgrades on the printers. Also do those landscapes. I print out 3D landscapes, and one of my jobs is to create maps for Iceland, and I use the data I have from that job to create very detailed 3D models, and then I paint them out with acrylics. And I've done like time-lapse video of me painting, and also just a slow TV style live stream with me painting for 2 hours. So I do a little bit of everything, and for all of us, I put in the video description a link to our channels and social media links, Twitter and Facebook and such information, and so you can check out everybody's channel and subscribe to everybody, and also on this Friday Hangout channel, so you will get notifications. But that's me, and I wanted to have this this session here on I think I was locked on Dawn. I wanted to have this sorry, the camera was locked on Dawn, so I couldn't show you the paintings, but these are the 3D printed landscapes I'm doing. So I want to show you those. But I wanted to have this conversation about material testing. Last Friday we got really good session with Matt from Printed Solid on different materials for different applications. And this was kind of like a follow-up of that topic on how we actually test filaments and materials. And there's a lot more to filaments than just how it looks. We got all kind of materials that look nice, but a lot of people are using 3D printing for mechanical parts and practical prints. And I thought it would be a good idea to get a professional view on this topic and invite Stefan to this session. So that's he is doing a lot of engineering great videos on his channel with some words I don't always understand. But it's good content and gives you ideas on how to test things. So to start off, I want to ask Stefan a few questions, and then we'll get into discussion If you have questions in the chat, we will try to answer them as we go along. But for starters, Stefan, you mentioned you work in your profession as an engineer in an engineering firm, and you apply those methods. Like your equipment that you have built around filament testing at your home, is that like a homemade version of similar devices you're using, or how to come up with the methods that you use in your videos?
Okay, well, so yeah, as I said, I work as a professional 3D printing engineer, and we do lots of material testing in order to just characterize our materials. And for us, it is very important to take a look at specific properties like static strength, impact strength, and all of that which is connected there. So I do know how the methods work. I do know which standards are usually used. And one of the good things is that I have access to many standards that are used for testing these materials. So I usually don't trust nobody. So if I really want to find out how strong a material is and how good I can print with it, I just want to test it myself. And in order to have tests that are reproducible and comparable, I thought I need to, well, make myself some kind of a test rig in order to test the filaments. So the first machine I actually built like 2.5 years ago is my tensile testing or universal test machine, which is just kind of a wood version of a professional one. So where you put in a piece of material, just load it in tension and then record the point when it fails. The method itself is not really complicated, because you just load a part in tension, and you have a load cell and record the data, and then you just put it into a graph, and then you can compare different materials with each other in terms of strength and in terms of stiffness. Some of the further equipment I have built are also partly influenced by the videos that Tom used to do with his Filawin series, where he also has been testing the impact strength of materials. So I also built myself an impact test machine, because I wanted to figure out which materials can also be used in a more realistic scenario. So if you drop something, or we've just before talked about quadcopters, which materials are suitable if you have forces that act in a short amount of time. So I again just have been taking a look at the standards, how it is done in professional machines, and then I tried to adapt these methods in a way that I can build the machines on my own. And as you might have already seen, most of my machines are just built out of wood, because this is the material it's most easy to work with for me. And just now, over time, I'm increasing the equipment I have around. It is definitely not in a way as professional as if you would buy a commercial machine, but I think it's already a step into the right direction, because it enables me to test materials in a standardized way and then compare them to each other. In order to maybe stand a little bit out from the test that also Tom used to do in his Filawin series, I tried to use more engineering numbers. Like you have seen the megapascals for the strength of the material. You have seen the megapascals for the Young's modulus. Impact strength is a way different thing. And when I started 3D printing, I was always looking for these numbers, but I did not really find them in a way I liked them. So I thought I want to make them my own. And I know that there are lots of other engineers around who also would like to have the strength numbers in, well, in a way they usually know it from normal data sheets of polymers or metals. So I will just try to go into that direction. And I think it's working out kind of well. I'm sure that the way I'm doing it is not suitable for everyone, because it is a bit, well, engineering influenced. Not everybody knows what a megapascal is. Not everybody knows what KSI or PSI means. But this is the thing. You gotta stand out in a way, especially on YouTube, because otherwise you're just one in a big mess. And as I said, yeah, it worked out pretty well for me, and I'm just trying to go more and more into that direction, because I see the need for these numbers, and I have lots of people just asking me, how did I build my machines? Are they open source? They want to build them on their own because they also want to test the materials. I'm currently getting all of the data and CAD files together that I can release them for everyone, because there kind of is the need to do that, at least for some. And yeah, I'm always looking for new tests just to find out how I can characterize materials even in a better way. And yeah, so currently creating my videos, reading comments, and if there are some feasible comments, I try to implement them in my tests.
Yeah, and that maybe comes to my next question, because what I started to do with filament reviews, and I'm doing a lot of the MakerBox reviews where I test out those, and I have a limited amount of filament to test. But one of the things I started to print out was those small parts, and to find out if layer adhesion was good, I just was breaking the part with my hands to get a feeling of how difficult it would be, and I started to try to do a more standard or repeatable way, because this is just a feeling in my hand how difficult. So I built this small device where I can load the part in and pull on it, and this has just like a weight device here, and I can read the value of the screen. But what I found with this device, I got a lot of variation. If I test 10 samples, I would get maybe 10 to 15% difference in between the same material or same print. So my next question is, with the gear that you have built, how accurate, if you test out the same print with 10 items or the same material with it printed at the same time, how accurate is the methods? Because in the videos you only show one part breaking apart, and then we see the value in the graph. But how accurate do we get?
So, well, I usually do 3 tests, and if you load the material in printing direction, so in the XY plane, the results are most of the time really consistent. But taking a look at layer adhesion, and this is, I think, what you also have been doing in your tests, which I actually have seen, and I find them pretty interesting. And I think you're doing a great job there.
Yeah, thank you.
I have actually seen that layer adhesion is something that can vary a lot. So I also often have standard deviations of 10, 15, 20%.
Yeah, okay.
So I think that is pretty normal. And this is still one of the things that is kind of a problem with 3D printing, or at least with like hobby 3D printing, that the results are not always 100% repeatable. They're not 100% consistent. The question is where they're coming from. Is it a problem of the material? Is it a problem of the printing process? Or is it just a general scatter of the material? But even I think even that is a result, that results scatter. And then you can investigate more what could be the reason for that.
Yeah, and like when I was doing some improvements of my device, and I printed out 100 samples of this to measure out the deviation between parts. And so if you're seeing 10% in change of layer adhesion, then that's a similar result as I am finding with my device. So that validates that my device is not maybe horrible. It's just a process of testing in this way. It's not so accurate. But before we continue, Ben Hawk3D joined us, and Ben, if you want to do your introductions, before we continue on.
Hello, can you hear me all right?
Yeah.
All right. Hi, everyone. Sorry for my delay. I'm always late. It's really bad. So unprofessional. Slap wrist for me. Yeah. Hi, everyone. If you don't know who I am, I'm Ben. I used to have a business called Hawk3D Proto. I'm now a full-time content creator on YouTube, and I do some other stuff off YouTube as well. Mainly 3D printing. Absolutely love it. Love the industry, and I'm incredibly passionate about what I do. And if you want to follow me, you can do, and make sure you sub to this channel, because everybody who puts time and effort into it, Martein's a huge part of it. I mean, he does it every week, apart from the week when he was in Barcelona. I've got to give him props because he's always hosting it. And if you hear any noise in the background, it's probably my two dogs. So apologies in the advance.
Yeah, thank you. And then on to maybe next question for Stefan. I have to question him until we run out of questions. And with the material testing, do you find, like with the nylons that are really tough, it's very difficult to break apart nylon, and have you found out like what materials, what properties, like different properties means that you can use it on different applications, of course, but have you found that you can't really measure this, like with a brake test where you have the hammer dropping, and if the filament like is a flexible filament, then that would not be a very practical test. So what is your thoughts on different types of filament in regard to testing? Do we have a lot of different methods of testing?
Well, yeah. Well, this is the reason I am slowly increasing the amount of tests I do for my filaments, just to really figure out each of the properties that might be important for the thing you want to do with it. And if you're speaking, for example, for nylons, if you do a normal tensile test with it, it will not break. It will flex a lot. You will get, plastic deformation of the part. But this is one of the reasons why I'm not only taking a look at the maximum strength the part was able to get, but I am also taking a look at the strain the material can withstand until it eventually breaks. So this property is called ductility, and the ductility of a material can give you an indication how good it is if you, for example, overload it. So it will not fail abruptly, like, for example, a PLA. But then this is also not something which is applicable for everything, because, for example, a PETG might also have quite a high ductility, but if you load it very fast, it will also break in a brittle way. So for this reason, I also take a look at the impact strength, and the impact strength gives you another indication how will a material react if it is loaded in a fast way. And then, depending on all of these results, including temperature tests and also a bit more realistic tests where I load the hooks in tension, I try to figure out what the material could be suitable for. But this is always a combination of the strength of the material, the ductility of the material, the stiffness of the material, which is also very interesting. The impact strength, temperature resistance, everything which comes together. You cannot say there is the one perfect material which is suitable for every application. This is kind of the holy grail of 3D printing. But depending on your needs, you need to choose the right material. This can sometimes be only print quality, and then there is the PLAs which stand out. But also, if you're only taking a look at the strength of materials, PLA is one of the strongest materials out there if you load it, if you don't load it fast, and if you if you do not overload it too much. And PLA is, for example, also one of the stiffest polymers out there. But if you have an application where overloading can occur, more ductile materials are better for that application. But more ductile materials, for example, ABS and nylon especially, have the problem that they are not as stiff. So even though they, well, can withstand some kind of an overloading, they might flex too much and therefore also cause problems in your machine. So for this reason, there is not the perfect answer to that question. There is not the perfect material. Depending on the application, you need to find the material that is suitable for that. And this can highly depend. So for example, well, we have been talking about quadcopters before. I think PLA is a great material for that application because it is stiff. So you get a really rigid frame. And it has a high strength. So even if you have high accelerations during flying, it, well, shouldn't flex and shouldn't break. But if you crash it, it will look pretty bad. But usually if you are kind of a professional drone flyer, this shouldn't be an application you design your part for. But if you are, for example, a beginner, you might it might be a good idea to take a look at materials that are maybe a little bit less stiff, maybe a little bit more ductile, and can cope with, well, a crash or something like that, and you don't have to rebuild it all of the time. So as I said, always depends on the application. Think about what you really want to do with the part you're printing, and then figure out which material property is important for you, and then choose the material that is suitable for that application. And well, money is always a consideration. There are really good materials out there, but if 1 kilo of material costs you like $150, it might not be worth that money, because maybe printing more spares, breaking some of them, but always just replacing them might be cheaper in the long run.
Yeah, I'm talking about like expensive filaments when we have like the carbon fiber infused filaments, and people say that it's an extra strong filament, but like layer adhesion is maybe not very good, or people very often don't get information on in what applications those are strong, because it's layer adhesion can be bad, but it can have different properties, so it won't bend, or it's difficult to
or you have to design your parts in a way that they are only loaded in the strong direction, in the strong printing direction. Then carbon fiber materials are pretty strong, but if you load them like transverse to the layers, then they are not stiffer than the base material they're using. So people often don't see that. And this is one of the things I, for example, like to show in my videos, that carbon fiber materials are really strong. They are really stiff, but if you don't design your parts in a way that these parts take advantage, you will not have better results. If you will not get better results than, for example, using a cheaper PETG or PLA filament.
Yeah, and I think now I've been asking you questions for half an hour, and I'm gonna let the other guys pitch in.
I think George just wanted to say something.
No, it's just the variability in it. It's basically what. First of all, what I hats off to you. I'm gonna take my hat off. I'm wearing my hat because my hair underneath is fuzzier than Stefan's at the moment. So, trying to keep a professional appearance. What I like is that you're actually putting it through the test of being printed, and being printed with machines that are readily available to people. What we're finding is that a high-end machine will print much better. It'll be more reliable in the way that it actually produces each individual layer, each individual bead, and the cross-linking that happens while you're laying it down will be different from printer to printer. And Big Rep have put a lot of effort behind understanding how to reduce the voids, between layers, and also between the shells, for instance. Ultimately, all the numbers that we get from a factory are for injection molded parts, which means that they've taken a PLA, let's say, and they've granulated it and they've pressed it into a standard measurement block. And these are what Stefan was talking about earlier when he's saying he's got access to the standards. There are standards that dictate what shape, size, and what loads you need to do it and which way you're going to go around doing the detention. But coming back to my point is there's a huge difference between what is printed in strength, the properties of the filament as it comes out of your extruder after it's been re-extruded, and how that translates to the real world scenario of your 3D printing. So yeah, hats off to you, Stefan, for that. I mean, it's to me, it's been eye-opening in some of the materials, and I'm glad that you're actually saying that the PLA is one of the better materials to use as an all-rounder. Most of the stuff I do for my own use in engineering stuff will be ABS if we wanted to do something that's abrasion resistant. But if you wanted to make gears, for instance, I wouldn't swap PLA. It's amazing for gears. We see it doesn't wear out. Whereas ABS, maybe it's because it galls, it sticks between each other. But yeah. As for material selection, well, even in metals, you have to select your materials properly, right? You can't just say that I'll use aluminium for everything. If you do want to use aluminium for everything, like Stefan says, you need to make it beefier than you would for steel, which might, on the balance of things, change the thicknesses of your parts or the weight of your parts. In the flying environment, you would want to select a material that will give you maybe the rigidity or the flexibility, the abrasion resistance or the impact resistance, depending on which part of your flying apparatus you've got there.
Yeah, definitely. But I have to give kudos to some companies that are actually putting numbers into their data sheets that are coming from 3D printed samples. I think Ultimaker is doing that. If you take a look at their technical data sheets, Polymaker, I think, also has printed numbers in there, but there are a lot of different, other companies that put injection molded strengths into the data sheets of their 3D printing material. And it might be comparable if you load your part in XY direction, but it is definitely not comparable if you load it in Z direction, so just transverse to your layers. But I also just need to point out that PLA is not PLA. So PLA is just the base resin, and kind of every extruding company, or maybe not all of them, but many extruding companies, they mix their additives into the material in order to make it more suitable for 3D printing or to make it more suitable for different applications. You kind of see in the last couple of months more like plus PLAs or tough PLAs coming on the market, which are way more ductile than standard PLA. They are not as stiff and not as strong, but they are they might be suitable for even more applications than your standard PLA. Maybe for some they are not as good, but for many others they might have comparable strengths than, for example, or as an ABS, for example, because they do not break upon impact. They do not fail brittly, but they still have the problem with temperature resistance. And this is, I think, one of the most important or the biggest problems of PLAs, that they just get soft at 50, 60 degrees Celsius. If that wouldn't be the case, PLA, a slightly modified PLA, which is a little bit more ductile, would be my go-to material. It prints great. It doesn't smell. It is very stiff, 50% stiffer than ABS, for example. It is way stronger than ABS, but yeah, the temperature resistance is just not that good.
If I could jump in really quick, I had a piece I'm testing out. It's a frame for the Piper 2 3D printer, and it actually, one of the ways it was designed, so it sits like this part here, this corner, sits like this on the printer, and then each of the ends caps that go on sit like this, so you have the lines, print lines here and print lines there. And the idea is that theoretically it should, so you've got print lines going this vertically here and horizontally here. That should give you extra strength. I printed it, in this case, I'm using this is a Chinese PETG, I think. So this is my hypothesis, not being an engineer, is that it has a lot more additives because it requires, it needs a higher temperature to print, whereas something like the DOS filament or the Hertz 3D PETGs I've been working with will print it in the range of 215, 220, maybe 225. This is 240. And then
yeah, so that's basically PET is a sad story for every extruder, every manufacturer of filaments. It's a very difficult material to actually produce in good qualities. And that's why they started working with the G, the glycol in it. That additive makes it printable and makes it extrudable much easier. Now, if you were to tell me my PETG is printable at 220, I would say you've got a substandard material, or it's been modified beyond what a PETG should be. PETGs have, I mean, straight PET, like the water bottle type stuff. You'd only be able to extrude it, past the 250 degrees. With a glycol, you're bringing that down. With a few additives, you're bringing that further down. Now, if you're saying you got 220 degrees, then they've mixed in some other additives, which may give it more ductility, or it may give it more impact resistance. I don't know what it does to the stiffness of it, though. That's maybe Stefan will be able to chip in on that.
Well, I gotta be totally honest, I'm not a polymer expert there, but maybe one thing I can add is that the standard PET you find in the bottle is in the normal PET. If you extrude that, it crystallizes out, and this can cause problems with warping, for example. And the glycol in the PETG results in a more complex polymer, and that reduces the amount of crystallization that is happening. So it stays more amorphous, which gets rid of some of the warping problematics. So it doesn't contract that much anymore when it cools down. And it makes it more ductile. So there are also PET filaments on the market, but they are way harder to print with in comparison to PETG filaments. And the PETG, as you already said, just makes the material, it helps it to flow through the nozzle and makes it printable even better. But I have been working with lots of different brands of PETG filament, and I found that there can be quite a lot of difference in terms of how it is printable, how it sticks to the building platform. I had some materials that just didn't stick at all. I had some which just worked great. So there is a lot of modification happening, and probably lots of manufacturers have their different 5-spice powder mixture in their materials just to make it in a way that it is better for 3D printing. But if you buy cheap, they might just be using the standard resin they can buy and modify it. Well, not at all. So you maybe have higher printing temperatures. It might not be as well printable as some other brands. And for this, it might cause more problems during the printing process.
Have you actually found materials that don't stick to the bed, Stefan? I mean, PET, as soon as you put it down, let's say on glass, we've always been seeing that people are pulling the PET off with the glass, right? So that's the classic example, and I know that from experience, at least with our PETs, it doesn't particularly like to do supports because it sticks too well. So
Yeah.
you've had experience with
I had issues with that, but that might have been like 3 years ago or something like that.
Right, okay.
It's way better now, but there used to be problems. And one of the things I've also investigated a couple of months ago is that PETG, or the printing behavior of PETG, can be influenced by the moisture content in the material. So if you have a really dry PETG, it prints out so great. You don't have any stringing. It is not as brittle as you might know it from time to time. But as soon as it gets wet, you get stringing. The prints don't look as nice anymore, and the material properties change as well. So if you have applications where strength and ductility is needed, just always think about that drying your material might benefit you during the printing process, and with the material strength you get out of your print afterwards.
I tend to avoid printing with PETG if I know it's something that needs a lot of supports. I would rather do something, as Stefan said, like one of the PLAs or something like that has a little bit of ductile qualities more than a standard PLA, but that I know if I have a lot of supports or that's necessary, the adhesion is not going to be a problem where I'm destroying the part. But going back really quickly, we started before we jumped on and started the stream. Stefan and I were talking about a quadcopter. You might see the one up there, but I printed one of his, a smaller one. It's I think a 5-inch or 4-inch, but I printed it in PETG, and the idea was to print it in PETG because it has the ductility. It has the it's a little more forgiving than, say, a more rigid PLA. Yeah, there you go, exactly. But the idea for me, and my testing currently, is to try to have the frame, since it's smaller, you can have a little bit of more, my theory is you can have a little bit more of a flexibility in the actual material that would be more of a problem if you printed, say, a 450 size in PETG. Then you have a larger area, and any kind of flex is going to affect your flight characteristics.
Yeah.
I have one question for Stefan. Stefan, have you tested out ASA filament?
Yes, I have done that. This was actually one of my first recent filament tests I did with the setup I'm currently using. It was one of, I will pronounce that the wrong way, Filament Trecek, some Slovenian company.
I got mine from 1-3D.
Yeah. So ASA is very comparable in its properties to ABS in terms of printing odor and all of the things that are connected to that. But the advantage of ASA, in my opinion, is that it's UV resistant. You can also
ASA is a very good external, like outdoor material as well, isn't it? You know, bird houses and stuff like that as a general application, if you like, for the community, I guess. But I've had some excellent results with post-processing of ASA, you know, just from like being that opaque white color there it is, because it's kind of off-white and you don't really have to prime it either. So I've had some fantastic results with just coating it with spray paint, you know, directly straight onto it, because usually I have to sand it, prime it, sand it again, and keep, you know, really smoothing it out. But with ASA, I've had some really fantastic results.
Yeah, here's the test print that I did with ASA. I only had something like about 5 meters of ASA, so there was not much that I could print with it. This was a sample that I got from 1-3D here in Germany. However, I had to print this with 280 on the nozzle and 75 on the bed. And
Sounds about right.
Yeah, I mean,
So
200
straight ASA will do that for you.
Yeah.
You'll find like there's you've probably seen these ABS X's or ABS Pluses. There's the equivalent of ASA as well.
No, I was just wondering about the ASA.
No, it's a fantastic material.
Are you printing with an all metal heat break?
No, I was printing this with a normal brass nozzle.
With a brass nozzle, and you had a PTFE tube that went into the heat break.
All metal.
Oh, okay, good.
Yeah.
Yeah, because a PTFE tube will start to off gas at about 245. Correct me if I'm wrong.
No. The Hönow D9 officially comes with an all metal hot end, and I was lucky enough.
Stefan, what kind of tests are you doing with ASA at present?
I've just been using it for one filament test. So I did the normal tensile tests. I think I didn't do any impact testing at that point, but I might be wrong there. I also tried out if you can increase like the layer adhesion if you vapor smooth it in a similar way as you can do it with ABS, but that didn't really help. It just made it look better. Temperature resistance, strength, stiffness.
It's about the same as the
as my current ones.
With we have a friend who bought the first batch of ASA that we had, and I think he's still using it in the bottom of his bucket to wash his car with. And that's maybe 2 years later. Just like any other filament or any other plastic with the styrenes, it does absorb moisture. So, coming back to an earlier point that we were discussing, you should really be drying your filaments, even if they're brand new. If you want to get the best performance out of them, get yourself a food dehumidifier or desiccator, or invest in a print dry. If you've got the extra cash, splurge out and go and buy yourself a mass portal one. But realistically, even the best quality filament will definitely benefit from being dry.
George did really well then not to plug his own website for the mass portal print dry then.
You know what, the mass portals, I mean, they're a fantastic machine, but you really need to be able to have that kind of money to be able to justify it. I mean, we had government departments buying it. They bought a number of them, but if you're doing peaks, ultims, and nylons all the time, they're perfect. But if you're doing that all the time, you might as well buy a 2-3 kilo spool, which doesn't fit inside the mass portal. So
you can invest like $1,000 for a kilo of peak. I think a filament dryer isn't gonna set you off that much.
You saw there was quite a lot of them actually with integrated filament dryers at the Forum Next, right?
Well, this is very important because if you are working with higher technical materials, most of them are susceptible to moisture intake. Yep. So if I buy a 3D printer, a professional one, which costs quite a lot of money, and I want to print professional materials, I want to store my filament in a place where it keeps dry, and not like the beginning of the print when the spool is fresh out of my dry box is great, but then like half a day later when the rest of the spool has already been taken up moisture just from the from ambient, then my print results get worse. So this is a very important thing, and I have been starting to dry all of my filaments, all of my good filaments, just when I receive them, and then I put them into my dry box, which is just a big IKEA box with like a kilo of desiccant, a desiccant in that, and that works pretty well. And it depends. I usually dry my material just in a food dehydrator, which works great. But often I just put it in my normal oven in the kitchen. And if you don't heat it up too much, I think you will not run into problems with like contaminating the food you are making in that afterwards with plastic outgassings.
Stefan, do you live alone? Because in my house, if I were to do that, I would be sleeping in the basement. I
No.
can't be doing that. You what in the oven? You know where you sleep? Oh, okay.
No, I don't live alone. She is always giving
She's
me.
forgiving, then.
Well, she's forgiving and she respects what I'm doing. But this is the reason why I bought a food dehydrator. And I've also, well, I'm from south of Germany, from Swabia, and the Swabians, you say about the Swabians that they always look for their money. So I have been taking a look how much energy I use when I dry the filament in my oven in comparison to the food dehydrator, and it's pretty much the same. So it doesn't matter if where I put it. And the food dehydrator I only use for drying polymers. I will not put apples or something different in there. So it doesn't matter if I ruin it.
Stefan, I have a question for you, if I may, regarding adhesion solutions. Obviously, it's still material based. What have you tried? What do you like, and what don't you like?
Well, if somebody is mostly printing PLA and has a glass bed, a Printer Pro, a Printerfix is the greatest adhesion spray there is, in my opinion. I'm using it every day at home. I'm using it every day at work on our Ultimakers. It sticks, well, the prints stick so well to the hot print plate and they just pop off as soon as it cooled down. If you're working with other materials, it is, well, not the best anymore. It's great for PLA and it's great for glass beds. Otherwise, I've also tried a printer stick, which works a bit better for like ABS, ASA, nylons, and things like these. But it is sometimes too strong that I actually, it's hard for me to even get the parts away from the building platform. What else do I have? Yeah, I have Magic Goo. Magic Goo also works very well, but you have to reapply it, well, after each print. This is one of the things which is also great with the a Printerfix, because you can just apply it on your glass bed and it will be great for the next 10, 15, 20 prints.
That's interesting to hear about Magic Goo, because I've had like 4 or 5 decent prints out without having to redo it again.
Yeah, well, maybe I just, I'm a bit afraid if I see some of the Magic Goo being ripped off when I remove the print from the building platform.
Okay. Have you tried this?
That's good stuff.
And you can get this from George if anybody's wanting to buy it.
No, I haven't tried.
That's better for high temperature though. So that was developed for prints that go up to like 80 degrees, 90 degrees on the bed. The hotter it gets, the better it'll stick, ABS especially. For low temperatures, I mean, you probably saw my face there going no on a Printer Pro. And the reason I don't like a Printer Pro is not because of the product itself. It's getting it to clean the bed off. I mean, so we've always tried to go with the water-soluble solutions. So 3D Lac was the water-soluble of choice back in the day. Then it was Demafix, because we can use it at high temperatures. Again, you just run it under water, fine. With a Printer Pro, we had to get like an alcohol solution to be able to take it off. Acetone doesn't touch it.
Yeah, it doesn't. You kind of get rid of it with isopropanol, but I usually just take my whole print bed, take it to the kitchen and use hot water and dish soap and a brush and clean everything off.
Stefan, I've heard that if you're printing with PETG on a PEI plate, what you need to do is use a glue stick
as a separation layer.
As separation layer, correct.
Yeah.
Yeah,
it
I
can
use
happen
Magic
that
Goo as separation layer. For
yeah. That's what I also do. Magic Goo works great for that. because it still keeps the parts sticking on the print platform, but it doesn't rip like pieces out of the PEI sheet. I really need to get in touch with what's the name of the magic goo? Andre again, because he
Edward.
Yeah, I know. Well, I know Andre. I walked by him on Forum Next, but I didn't recognize him 100%, so I didn't talk to him. Well, anyway, they have their new formulations for polypropylene, for example, and other like non-standard materials. And I would really like to try these ones out, how good they are working, because I really like printing with polypropylene because the layer adhesion is great. I think it's a great replacement for many other flexibles, but it's just a real hassle to get it to stick to the print platform, because you have to use like packing tape, polypropylene tape, in order to get it to stick. But otherwise, I think it's a great material for specific applications.
Yeah, I got all three.
That's what got me excited about Magigu. You know, I spoke to them at TCT, and they showed me that package that Marteinn has got there, and that got me really excited with trying to work with them.
Did they not give you one, George? They were walking around with them, and then they walked past me with one. I was like, I used to be a distributor. You're not going to give me one.
They gave me quite a few of the condom packs.
That was a bit of my feedback when we first got those sachets. I was like, they look like something they shouldn't. You might want to rethink that one.
So what I'm using is a simple liquid paper glue that I found on a local store in Switzerland, and I don't know, it works so well that I haven't touched my magic glue for a while. And I will give one to Stefan so he can give it a try when I give him back the printer. And if you peel it off, you see it's like this. I don't know, it's kind of like a tape or something. So it works really well. So I think he missed it. Stefan, I'm going to give you one of these bottles here. You can give it a try. It's a very cheap liquid paper glue, and it works really well for me. As a print adhesion. But I don't know what the formula is. I don't know what's inside.
Well, I don't know why, but somebody was being cheap with me. I only got this package.
The condom pack.
Yeah. Unfortunately, for the projects that I print, this will never be enough. Because
they're good though, aren't they? I mean, in terms of a marketing spiel, they're amazing, those little things.
Yeah. But I'm one of those type of persons that says print big or go home.
Oh. Yeah, one day I applied it to my glass bed, and then the top came off. Did it ever happen to you? So I spilled half of the bottle on the bed, and that frustrated me so much. I lost a lot of magical there.
Yeah, if you squeeze the bottle without pressing it down, it will pop off.
Tom actually posted a really nice picture.
Yeah,
today.
So
he did that.
Half a bottle on his print bed is just flowing everywhere. Yeah, I have one question about the drying of the filament. Like if you dry a filament out, print partial part of the spool, leave it, dry it again, and do that several times, do you lose the mechanical properties of the filament by drying it out many times?
It can happen that if you dry it too often or at too high temperatures, that the additives get out of the filament. So what I usually do, if I have nylons, after I got them, I dry them, and then I directly put them in the dry box, which has a Bowden connector and a Bowden tube connected to it. So I print directly out of the box, so the filament never really gets in touch with moisture. So this is the way I avoid needing to dry the material over and over again. And this is working pretty well for me. For all of the nylons I use, for all of the PVA I use, all of the materials which are susceptible to moisture.
I actually haven't heard of anybody testing, how many times you can actually dry it. Typically, you dry it. So in an industrial setting, when you've got a hopper full of pellets, you will dry them as they're being used, and you'll keep them in a stored, let's say, environment.
Yeah.
For the filaments, the cycling, actually, that would be interesting to find out. But how do you test for that? I mean, are you going to take one piece of filament and keep going backwards and forwards and then trying that? I don't know.
Yeah.
I can
As I said,
imagine
I think it's the
Yeah.
better way just to keep it dry all of the time. If you have expensive materials, build yourself a dry box, print directly out of the dry box, and then you don't have to, well, then you don't have a problem with that. And especially, well, I have kind of been talking about that before. If you have a spool of nylon and you have a bigger print, you take it out of your dry box, put it on your printer. The first couple of layers might be totally fine because you have a totally dry material, but during the printing process, the remaining material that is on the spool can pick up moisture, and then after half of the print, the material starts bubbling again, layers don't adhere anymore, you get lots of stringing, so you don't, the total print is a mess.
Yeah. Oddly, I've never heard of somebody actually using, or nobody's ever talked about using a dehumidifier in the room that they're printing in. There's a part
You would
Well,
if you're in the UK.
Well, the dehumidifiers usually dehumidify up to like 40% relative humidity, and that is still too much for storing filaments. The dry boxes that I have a hygrometer in there, and the humidity is always below 10% relative humidity. And I think that is fine. As soon as you get, I don't know where where it's starting to pick up moisture, but at some point it does. And with a normal dehumidifier, I think you don't get down as much. And working in an environment where the relative humidity is below 40, 30, 20% is really unpleasant, because this is just not good for your sinuses, not good for your neck and everything. And also in a dry climate, all of the particles that are created during the printing process, they do not form bigger particles.
They do not adhere, right?
They will stay in the air, and for this reason, I just wouldn't recommend that.
Yeah.
Here's a thought. You know, everybody's going down the route of a perfect spooling. Yeah. Now, the first time I saw perfect spooling was when I contacted a company to do my matte PLA, and then suddenly you start seeing Prusa and a lot more people chasing it because it looks good. You can command a premium for it. What I would be interested to see is whether that perfect spooling also has an effect on how well you're able to dry out a complete spool.
Oh.
Because you're putting it in much denser. I mean, you see the volume, or how many coils you can get out of a perfect spool. Everything is a lot more condensed. So how do you get the air circulating between the coils that are closer to your hub? I'm not sure whether it's going to have that much of an effect, but sort of food for thought. And it's something that struck me while I was walking around TCT and seeing how many more people are doing this perfect spooling.
I think it depends on the material. If it's more a material that tends to absorb moisture more, you probably would see this being a bigger effect, especially as you're unspooling the roll. If it's something that's less hygroscopic.
Yeah, it's how you get it, because the reason the print dry works, or all of these dryers work, is because they don't just have heat. They don't just have something that absorbs the moisture.
Mm-hmm.
They work by forcing air out of the system. So that's what you want to do. You want to have dry air going through it as much as possible, not just heat. And if you've got a perfect spool, where there's no gaps for the air to go through, or at least any convection or any breeze to go through them, you're not actually moving away on the inner coils.
Yeah, NAC 3D Designs makes a point. On the flip side, it does help prevent moisture getting into the filament at lower parts of the spool. So it might be better for the filament to it doesn't get the moisture in as well as.
Of course, yes.
Yeah, it's a two-way process.
That's good stuff, Ben. I mean, he's done a fantastic job with his filaments.
Yeah, and I can't wait to try this color actually, because it really is like prominent, and my daughter's like begging me, like, "Daddy, print me something."
That's really cool.
Yeah, it's awesome filament. This is a print with a Prusament. The big
for anybody that hasn't seen it, I'll plug Marteinn. Marteinn's done a great review of it on his channel.
Yeah, I recently just made a video with a Prusament.
What color?
This is the pink one.
Yeah.
Have you tried that Prusament yet, Stefan?
I'll actually be receiving, I think, my package on Tuesday. I purchased 2 spools of Prusament like 2 or 3 days ago because I really wanted to get my hands on some.
Yeah, I have the black one, but I didn't unbox it yet.
Oh, the Galaxy Black is lovely.
Yeah, I think it was a Galaxy Black that I ordered.
Yeah, that one looks amazing.
That's Galaxy Black.
Oh my god. I better get it out of the box quickly and test it.
That does look nice, yeah.
Yeah, and I was getting excellent print quality with the Prusament. It was really smooth layers and very consistent. Like they print out the deviation on the spool, and one of the spools I got was 0.013. So they state it's a maximum of 0.02 millimeters, but one of my spools was 0.013. So it's really accurate.
I don't know. The engineering in me has, my reservations.
George,
like George,
you guys something.
Go on.
This is actually bold claim that Joseph is making, and I think he is able to reach that tolerance range, but I don't know if it's really that important for good prints. And one of the things I've been doing like this week is building myself a filament thickness gauge, which I can hook to my PC and run different brands of filament through there, find out how their tolerances is, and then print different samples and really see, is there a difference in print quality if you have a more consistent diameter.
I'll tell you where I had one example where a customer was raving about what we gave him, and that was he had an up exclamation, I think, one of those horrid old ones. It wasn't.
It's now like an Afiana, is it?
It was no. It's
you mean like an Up Plus 2?
Yeah, I think so. An Up Plus 2. That's the one.
Yeah.
And he was printing only ABS, but because the up takes 285, and he wanted to print 50 micron layers, it had an effect on how variable that the filament that he was using was. But at 50 micron layers, I mean, it's not every day that you're going to be printing DLP type layer heights.
Yeah, did you see the video Adam on CRT channel? He made a video. He was doing the calculations of difference in volume. If you extrude 10 centimeters of filament with different variation in the tolerances, how much volume of filament is really changed between 0.3 millimeter tolerance or 0.5 or even lower. So it was.
Can you post that video somewhere, maybe in the chat?
Yeah, I'll try to find it. Just carry on. I'll find it.
Would be really interested in seeing that.
Yeah, it was a good calculations.
It makes a huge difference if you start doing fat layers. So if you're at the point where you want to put down a lot more material, there is always going to be that small gap, and Big Rep have this metering extruder to be able to counter all that, because they're sort of trying to close the loop as much as possible. But for what we're doing in our hobbies or in our small, let's say, props, I think it might be a nice to have as opposed to a must have.
Stefan, that setup that you have there, I wish I had it here a couple of weeks ago. I had several rolls of, yeah, exactly that. I wish I had that here, because a couple of weeks ago I had 4 rolls of filament. They started out wonderfully, and then after about 20 meters, all of a sudden I started getting filament jams and under extruding, over extruding, and a lot of bull.
Where did you get these spools from?
From my normal filament supplier.
Is not disclosing.
I don't think we're in the business of naming and shaming tonight, so let's.
I can tell you.
That's fine.
I'll tell you fry out. That was 1-3D.
Okay.
And I was using this to measure, and I only use 1.75. And they say a difference from 0.2, and I was measuring 178.3.
But that's totally in the range you expect the filaments to be. So the normal range is between 1.7 and 1.8, which all of the printers should be able to cope with.
Yeah, but I mean 1.78.
Yeah, that's just 330 microns over the normal diameter. I think that is totally normal.
Just touching on that a second, Stefan. Have you tried Capricorn tubing?
No, I have not. But with these Capricorn tubings, I think they have an ID of 1.8. There, it's way more crucial that your filament diameter is kind of spot on, or even better, always a little bit lower than the 1.75 in order to avoid jamming.
Because I'd heard that they do like a really tight tolerance one, and obviously if the tolerance is out, then it's not going to fit, and then you're going to get jams, and it's going to be a nightmare. So, but then obviously, like everything else in the market on eBay, there's clones of Capricorn already, and it hasn't even been around that long. And you can go on eBay, and there's more blue tubing than you could ever want. But I haven't yet to use it. But I've heard stories where people have, if the filament isn't, within tolerance, that with these diameters, that this Capricorn tubing, it'll just jam it like halfway through, and like with the pneumatic coupling and stuff like that, it just won't work.
Yeah, I think with these Capricorn tubes, it's important that you use higher quality filaments. I am quite sure that there might be the possibility that if you have cheap Chinese filament, that you run into jamming problems, because I don't know if they are always meeting this maximum 1.8 millimeter diameter requirement.
Yeah. Maybe that might be a topic for you and Tom on your melt zone.
I bought a Capricorn tube for my CR10, and I had this issue with some of the filaments just getting stuck in the Capricorn tube. And I don't know. I think they say 0.8, and then there's probably some tolerances also in the manufacturing of the Capricorn tube. So you might even get a tighter Capricorn tube than they advertise. They must have a tolerance as well, so it can be a problem.
3D Gusner in the chat saying he saw a video where Protopasta got stuck in the Capricorn tube. Now, Protopasta is not cheap stuff. If that breaks and you spent an X amount of money on that, no matter where you buy it from, even the samples are fairly expensive, because it's, even I class it as a high quality filament. You're going to be out of pocket, aren't you? You're going to get frustrated, and all these other elements are going to fall into it. Not just the fact that you've bought tubing, but then you've bought a premium filament. All adds up, doesn't it?
Yeah. But Stefan, I mean, 1.75 is standard. Yeah. And if you have a difference with 0.2.
Well, but then you are at 1.95.
No, 0.2.
You mean 0.02?
0.02. Yeah. Difference. Yeah. And then you have a filament that's in your hand that's at 183.3. That's way out of tolerance.
183 would be out of the normal tolerance range of the plus minus 50 micron. Yeah.
Yeah. And
that should not happen.
No, and that's where I had 4 rolls of filament. That was a PET G and 2 different colors in PLA.
I noticed behind you, Stefan, you've got quite a number of Polymaker spools. Have you tried the Polysmooth?
I have actually tried the Polysmooth. I also have a polisher.
Yeah. Sorry, I've got a really keen eye, that's all.
Sorry?
I've just got a keen eye. Well, it goes with my name, Hawk, but
Yeah, well, it works very well. The process is a little bit easier to use than smoothing ABS because, well, the machine is working quite well with the vapor generator. The isopropanol doesn't burn in your eyes as much as the acetone does, and also printing of the Polysmooth doesn't smell as much as ABS. But on the other hand, also I think the Polysmooth material is a little bit susceptible to moisture.
Yeah, the only inexperience from my side, the only thing I found with that machine is that those filters are so like hypersensitive that if you get a bit of the isopropyl into those little filters, it like throws a hissy fit and it doesn't like it. And then, those things aren't cheap. So they could really think about re-engineering the connection of that, if I'm honest, because the way it plugs in is a little bit susceptible to getting that liquid in there.
Mm. Do you still have one of the older machines? Because I think they have changed their, how's it called, their vapor generator during...
Yeah, mine will be an old one because mine's from their Kickstarter campaign.
Ah, yeah, they re-engineered that. There is a second version of the vapor generator. Maybe they have fixed that bug.
Ah, right, okay. Mine's still the old school one.
Yeah, one question about with vapor smoothing on ABS acetone smooth. Does it affect I know it affects the look of the part, but does it affect the strength with the layer bonding and such, or is it just on the surface looking better?
George is nodding. I actually made that test when I tested my ASA filament, and I didn't see any change in terms of strength, in terms of layer adhesion. But I really wanted to take a look at that topic at some point in the future concerning ABS, because this is something which might be really interesting with vapor smoothing. What I did notice that the acetone you use stays for quite a lot of time in the material. So if you test it like just half a day or a day after you vapor smoothed it, it is still really soft, and you kind of have to wait like a week or something like that until all of the acetone has evaporated out of the material, and you get material properties again which are in the range as the material used to be before vapor smoothing. But this is something I really want to take a look at, but so far I didn't see any improvement in my tests.
So with ASA, like you said, ASA doesn't dissolve as readily as ABS. So if you were to use a virgin ABS, where it's the kind of thing where you would put it in, and if you leave it in too long, it will dissolve. That kind of ABS has significant changes in properties. Now, depending on how well you've layered down, how many skins you've got on your print, you might find that it's actually detrimental or actually it improves. So it's you're smoothing it for fatigue. We start talking about fatigue because you don't have the stress raises on the surface. Obviously, it will be better. Again, depending on how many layers you've got behind the first skin, right?
Yeah.
If you just got 2 skins, then you've lost, let's say, 1/10 of your thickness there and then, right?
Yeah.
But if you make it more thick, then you can actually get a better layer adhesion, at least on the outside surfaces. And that's where it starts running. You do not actually lose any ABS from what you're seeing. It's just flowing. It's flowing into where gravity allows it to flow, or where surface tension allows it to flow, or wants it to flow.
Sorry, everyone. I'm just going to have to jump in there and just say thank you so much for having me. I'm going to have to part way and leave the chat. Thanks for having me. Good to chat to you all, and thanks. Good to meet you as well, Stefan.
Nice meeting you too.
Good to see you, Ben.
Bye,
Yeah.
Ben.
Bye-bye.
Take care.
Thanks for having me.
Hope to see you tomorrow.
One more question just to ask Stefan. What's your favourite slicer?
Slick 3R Prusa edition.
Thank you. See you guys.
See ya.
Yeah.
Bye.
I'm actually quite. You probably can hear from my voice that I'm not in a particularly good state. So I think I'll follow Ben out the door. Stefan, again, really good to have you on here. It was very nice to talk engineering with a nice group of people here as well. Marteinn, thank you very much for hosting it one more time. And the rest of you guys, well, it's a pity I didn't bump into you when I was in Frankfurt.
Yeah, I was there too on Thursday and Friday, but I didn't see anyone.
Yeah, I was walking around. I mean, the Thursday I went, I was trying to see what I didn't see on the Wednesday, but I don't know. Everything was lost in the noise of too many cool things. So next time, what we'll do is, since the contact has been made, next time I'm in Germany, I'll see who else is there. Okay.
Perfect.
Yeah, we should meet definitely.
Well, George, I'm always in
George.
Take care, guys.
Yeah.
Have a
Thank you
lovely
for
night.
tuning in.
Thank you very much for having me.
Get better
Bye.
soon. Bye.
Ciao.
Yeah, it's been a informative discussion.
Yes, it was.
Yeah, I couldn't say much about it. Most of the time I was only listening. But it's interesting because I'm a dental technician, so I talk about flexor strength, a coefficient of thermal expansion, Vickers hardness, and all that kind of stuff. But it's more related to resins also, but ceramics and alloys, and abrasion.
Yeah.
Toughness,
Talking about resins, have you done any strength tests on resin, Stefan?
No, I haven't done that so far. I'm planning to make some tests when I'm getting my desk 3D back.
But I said, you just tell me when I should return it, and then I'm on my way. So
I have so many projects at the moment that and not enough time. So it will come at some point. I'm really interested in that because just feeling the prints I did so far, they just felt totally brittle, and I want to characterize it in a way that I compare it to standard or FDM 3D prints, and also take a look at tough resins, for example, if their applicability is better for engineering applications. But I haven't done anything so far. We'll be doing that at some point in the future.
What I found out, it's really important that you cure it, because off of the machine, it is sometimes so soft. And then when I put it in I only have this kind of nail curing machine. But it does its job. And it's really incredible how much stiffer and harder it gets once you cure it. Yeah.
If you would like, I have a good friend that's TK. Marteinn, you're also in my Discord. If you want, you can send TK a invitation. Maybe he'll jump in. He is my resin specialist.
Yeah. Okay. Yeah.
TK, the turn cam.
Yeah. Let me see.
Yeah, Martin, you know who he is, right?
Yeah, I also know. Turan Khan. I think he's also a German guy, isn't he?
No, he's from the UK.
Oh, he's from the UK. Okay.
He's from the UK. He printed a couple of parts for me already for my Star Citizen Hornet.
Okay.
I'm not sure if you want to see that, but he has a Moai and a Anycubic Photon. And yeah, for example, that rumor about resins, that you have to take them out of the vat, you have to filter them, put them back into the bottle. That's all birdwash, let me say. And I'm pretty sure that TK could tell you something a lot better. The parts that he printed for me, the landing gear and the weapons that are on top, those things were printed with a resin that was laying 9 months in the vat. And all he had to do is just stir it up a little bit. And he had to add some fresh to it because there wasn't enough in there to print the parts. But yeah, he printed the parts out and they're more than perfect.
You know that nothing will happen to it unless you expose it to natural daylight, because this is, you know, the window has to be orange. There shouldn't be any leakage. And I've seen so many industrial printers where I was really shocked that they have a gap, you know, on the sides where the window closes. But when it comes to the DAS, I'm really happy with the build quality of that one, because it really seals well. Yeah, so you should have a seal there, and the orange prevents it from curing.
Yeah.
Yeah, so you can just leave it in there, and as you said, stir it up a bit, and then it's fine to go. But of course, it has a shelf life, so I think on the bottle, on the back side, there should be written how long it is good. Yeah.
Yeah. No, but I found that really amazing. That
yeah. I'm also keeping it in there, and I'm having it in the vat now for 3 days, and when I print the next time, I will just carefully stir it up. One test that I want to do is I want to test on the castable ones if they really burn out, you know, the burnout properties. So I have some platen foil, and I'm going to put it in the furnace at the typical burnout temperature around 850 degrees, and I want to see how much ash is left. Yeah, because that would be interesting for me printing jewelry afterwards. You know, once I'm ready downstairs with my casting room, and yeah.
I was wondering, why do you use platen foil for that?
Because platen foil is something that you also use when you want to test waxes. Because there are some waxes that don't burn out 100%, and you know, we technicians, when we build up teeth, the classical way is you have a Bunsen burner, and you have little instruments, and then you heat them up, you dip them in the wax, and then you build up your crown. Yeah. Afterwards, you invest it in a you invest it in a heat-resistant material. And then you put it in the furnace, and then the wax melts out. And to test your wax, because there's some waxes that don't burn out 100%, you put it on the platen foil, go over the Bunsen burner, or put it in the furnace. And then afterwards, you can see if there's still something left. For gold or alloys, that would be still kind of okay. But when it comes to full ceramic, you can imagine that if you wax something up, put it in the crucible, you know, in the muffle, and then burn it out, and then later press in some glass ceramics or lithium disilicate, what we use in a dental industry, and then the wax didn't burn out, you would have like black spots on the crown. Can you imagine that? So therefore, you would clearly have to use a wax that burns out 100%. This is how you can test it.
Ah, okay. Yeah.
So you're using it to see if there's residue afterwards?
Yes.
Or how much residue?
Yes.
Yeah.
And you know, platen foil has a very high melting point. So there's also a technique where you where you wrap platen foil on a stump, on a plaster stump, you know, from the model that you get from the dentist, and then you burn ceramic on top of it, which is around a little bit lower than let's say 1,000 degrees Celsius. And afterwards, when the crown is finished, you peel out the platen foil from inside of the crown, and then it's called jacket. Maybe some of you have heard of jacket crown. Maybe the older ones when you went to the dentist before they had. Yeah, you know that before they had those pressable. Okay. Before they had those pressable ceramics, they used to make it that way, and then, you know, the peel afterwards you peel out the platen foil, so it's quite heat resistant.
Okay. Yeah. Well, and it doesn't react with something which is on there because it's kind of inert like gold.
Yeah. It's yeah. So afterwards you just peel it out, and it doesn't seem to create lots of oxides. Because normally, when you want to have a good bond between, you know, if you look at metal ceramic crowns and bridges, you create an oxide on the surface, and then afterwards you put on the ceramics, and that will bond really well. Yeah. So I think the platen foil doesn't create an oxide that a ceramic, for instance, could bond to. And then you can peel it out. I think it's also one of those properties. Yeah, so when it comes to metals and stuff, you know, there I'm more like an expert or ceramics.
Kat, I have a question for you. What do you do as a hobby?
Yeah, I also make glass beads on a lamp, you know. So I love glass.
Yeah. That you're an expert in jewelry, I see that already.
Yeah, but I'm not artistic. I cannot do any CAD design, so it's going to be a tough journey. I have to learn that.
Yeah,
Martin.
Yeah.
Sorry.
Yeah.
I think we drifted off quite a bit from the main topic. And
Yeah.
Excuse me. I didn't say anything for such a long time. Now I had to talk a bit.
Yeah. I found it interesting because I worked 3 summers as an assistant to a dentist. So I'm familiar with what you're talking about. So I didn't actually mind, but I was thinking this is maybe a little bit off topic. But on the talk of like casting, Mitz was pointing out there are wax filaments for FDM printing that you can use for casting. So that could maybe be something that you can have a look at for your jewelry making.
Yeah, I have some rolls here, you know, and I want to test that too. I want to test out the melting behavior, burnout behavior.
Maybe also something from my side on that topic. So I've also been investigating a little bit in that direction, and as much as I've heard so far, the wax filaments are kind of tricky to print, and the results just printing with PLA investment casting molds are really good. And I have been talking with Tom about that, I think already twice on the podcast, that he also knows a company that are doing lots of investment casts with PLA filament, and they are pretty happy with it. Polymakers also selling, at least in their industrial range, their polycast material, which is the same base polymer as the polysmooth material, but due to the lack of additives and colorants, also burns out very nicely, and you can vapor smooth it. And I have some of that in here, and I have already tried burning it out, and it gives really nice results.
Oh, okay.
But also normal standard PLA, if you burn it out, there is barely any residues left, at least in the things which I've done so far.
So which temperature did you use? How high did you go?
I have a how's this guy called? The King of Random. I have a King of Random crucible at home, which is a metal bucket which is lined with clay on the inside, and I have just a flame in there, so I do not know if it's 500 or 1,000 degrees Celsius.
Okay.
I use it to melt my aluminum outside and also to burn out my investment casts.
Yeah, I think he melted copper in his, so he's getting probably 900 or 1,000 degrees.
Yeah,
Oh.
no
in
problem
that,
there.
yeah, so it's quite hot. Yeah, but I want to ask about because we are talking about the materials, like with the engineering filament, like the Ultem and Peak and such filament. Have you done any testing with that at your work, or do you have any experience on how much stronger those filaments are compared to what we can do on our home 3D printers?
Unfortunately, not yet so far. I would really like to have a printer that can also print high technical materials. But in the first place, the machines themselves are pretty expensive and complicated because you need to have, well, a print chamber temperature, which is, which should start at 80 degrees and should go even higher. The nozzles need to be heatable up to like over 400 degrees Celsius. And also the print bed needs to get at least 110 or 120 degrees Celsius warm. So E3D are currently doing some pretty interesting things in this direction. They, with their new high temperature range of print beds, nozzles, and heaters, they bring more affordable things to also makers. And maybe at some point I can get myself some equipment to build myself a printer that can also print materials like Peak or Pack or Altem or everything which is in that range. But on the other side, currently I think 1 kilogram of Peak sets you back 1,000 euros. So it is not something to really play around with.
Wow, that's crazy.
1,000 euros.
Wow. I wasn't aware that it's that expensive. Oh my goodness.
Yeah, and if you have an ambient print chamber at that range, you pretty much you want as little of your electronics or even motors or things like that in your print area that's heated at that, because you're essentially, I think the figure I've heard, you're pretty much halving the life of your electronics, your motors, things like that, if you're exposing them to long-term prints at that temperature.
And you also need to be able to cope with the thermal expansion of all of the things which are in the chamber. Exactly. And this is also can be something tricky.
I can imagine it being a very specialized equipment because you can't have a power supply in an enclosure with 50 plus degrees in it. It will damage it really fast.
Well, I think stepper motors can quite happily run at 100 degrees Celsius, but each centigrade temperature more will reduce the lifetime of your electronic parts because it degenerates the the isolating, how do you say, the isolation layers around your conductors.
Yeah. Has anybody seen, I just saw someone did a video, this is a bit off topic, but for testing materials, the NEMA 17s with an encoder board on the back of them. Has anybody seen this?
I'm not an electronics girl, so I wish I would.
Making a servo motor out of your stepper motor.
Yeah, essentially, so you're able to see the steps loss and correct for it.
Yeah, I've seen on YouTube some video on it's like a closed loop system. So if you are printing and you push on the head in the same direction as it's printing, it will detect it and will recover. So it's a closed loop system that is. You have to have the electronics to sense what the motor is actually doing, and then feed that back to the stepper driver to compensate for the.
You don't actually have a stepper driver because it's happening on the one I've seen, and it's more common in robotics. The one I've seen that's going around now, basically they're tacking it on the end of a fairly standard NEMA 17, is the processing is happening on the board that's on the back of the NEMA 17 versus being handled by something like a TMC stepper driver.
Gustner already wrote that in the chat. It's called the closed loop NEMA 17.
Yeah.
Yeah,
It
okay.
basically makes a servo motor out of your stepper motor, so you are
exactly.
checking if a step was performed. There are some of these servo motors now available where the interface is the same as with a stepper motor, so you just say one step in which direction. But internally, the circuit is different because you have a closed loop system.
Yep.
The actuation is the same, so you just you energize the coils in your stepper motor the same way. But additionally, you check with the rotary encoder if the step was performed. When it wasn't performed, it tries again and tries again and tries again. Or in the other direction, if you overtorque your motor and it skips steps, it notices that and will go back to the position it should be. And this is something pretty cool. And I see this may be coming in newer printers in the future. But the way 3D printers are currently designed is that the motors are oversized, so the possibility of skipping steps is quite small.
Yeah.
Yeah, I was just Googling it. You could buy those steppers maybe $35 to $40 with an encoder on the back. So it's not so far-fetched to try it out.
That's not too bad.
And you can, from Velorad, you can get TMC 2130s for like 10 euros. So, yeah. Back to materials. I have not tried. I know one thing I wanted to mention that was curious about, as far as the off-gassing on like PTFE tubes, if you're printing at like 240, 235, 240, when does it get to a point where people should be concerned about, like, you don't want to be in the space when it's you're using, say, because a lot of people in the hobby will buy an E3D clone or something like that, and they'll use one of the heat sinks with heat breaks with that's PTFE lined, and then they think, okay, I want to try PETG, I want to try a higher temperature printing material, and there's not a lot of awareness that if you aren't careful at the temperatures or which heat break you're using, you can get off-gassing.
I guess if you are buying kits or, more or less readily built printers from China, usually in the firmware, they have a maximum temperature included in there so that you can't go over the 250 degrees. And if people are, compiling their own firmware and creating their own printers, they are kind of responsible for themselves to do that. I guess it's
tweak at your own risk is what you're saying.
At your own risk.
Yeah.
It's kind of the same thing if you cook something on your stove and have a pan on there which has a Teflon coating, and you forget it and get back into the kitchen and everything has burned off. I don't know if there is the awareness that the fumes in your kitchen might be really harmful.
Stefan, How I Do It has a question for you. What is your favorite filament test that you have performed?
Sorry?
What's your favorite filament test that you perform?
What's my favorite filament test? I really like testing my hooks because this is like a combined test of, well, a normal tensile test, a bending test, a stiffness test, a layer adhesion test. So the results tell me a lot. This is a simple test which tells me a lot about the performance of a material.
Yeah, with the hook that you put in your tensile strength device.
Exactly. So this one
Yeah,
right
yeah,
here.
this one. Yeah.
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 This is kind of stolen from, I think the guys are called Wolf 3D. I've seen them testing kind of a similar part on their side, and I thought it is a good idea. And since I started using that, I'm pretty happy with the results because, as I said, just with 2 pieces, one printed in this direction, one printed in this direction, you can already say quite a lot of things about the performance of a material. You see how ductile the material is, so how much flex you can get out of it. You see how it breaks. Does it break in between the layers? Does it break through the layers? And yeah, it's performed pretty simple. But maybe coming back to that, so I really admire your setup as well, Marteinn, because it is pretty simple and everybody kind of can perform these things themselves. I've been taking a look at your videos and I did not find a link to the parts. Did you release them somewhere?
No, I haven't actually. I should do that. There's been a lot of progress from where I started, but I think I'm at a good place now. I was thinking about having a motor to drive this part to have a very consistent speed, because when I'm pulling on it, I'm trying to do it at a slow pace, but it's still a human interaction. And if I'm feeling a little bit stronger or holding here or here at the end, it difference in strength and speed. But I really should just do a thingiverse item with all those parts. And this is I got this at a store where they sell equipment to go fly fishing. So they thought the hook at the end to weight out fish. So this goes up to 25 kilos. So it's just a makeshift device to trying to do a little bit more science than just doing this.
Well, you might be laughing there, but the same angles that you are currently breaking, this is also how I started, and this was where I have seen, okay, I need to build something for myself in order to get proper numbers out of it.
Yeah.
Have you done more research in the direction of what measuring devices you can use? Because I'm still looking for another one of these simple luggage scales that have a maximum load feature.
Yeah, I was trying to find that one here in the stores here, and I couldn't find one. And that's the one thing with I used my phone to record the screen. So I watched the replay of the video from my phone to get the measurements of the screen. But what happens when the part breaks, the load changes very rapidly, and at the break, just before it breaks, it's getting at the maximum really fast, and it's difficult to find.
You mean a peak hold feature?
Peak hold feature, yeah.
Yeah.
There is a hold feature on lots of these luggage scales, but this hold feature will usually start to engage way earlier than the maximum of your test was. And I'm looking for one of these devices because I've also been talking with Tom about that, of creating a measuring device where more or less everybody who is interested in making their own material tests can build a pretty simple rig.
Oh, that would be cool.
do these layer adhesion tests, for example, on their own, but I'm still missing one of these scales which has a max hold feature. So maybe somebody in the chat, if somebody knows a measuring device or some of these luggage scales which has a peak hold, it can also be an analog scale. Please let me know. I would be really interested in that.
Yeah, about the method that you use in your tensile strength, you said you had a like a load cell that you monitor.
Yeah,
that's a digital measuring device.
Yes, this is a professional load scale where strain gauges are on the inside, a full so-called full bridge, and there is a separate IC which is measuring this load bridge, and then I convert this measurement into a load which I calibrated before.
Yeah.
This is the kind of the same thing as you have in every kitchen scale. And if you have ever opened a kitchen scale, there's always like a bending bar on the inside. Just wait a sec.
I've seen one. Yeah.
And Gustner has a question for us.
So you have one of these always in the scales.
Yeah.
And this is basically a simplification of the load cell I also have in my machine. There are 4 strain gauges on this piece of aluminum. And when this part is loaded, you get an electrical signal from it, and you convert this electrical signal to a load which was calibrated before. And it's kind of simple, but in my opinion, still too complicated maybe for many others out there who just want to buy or build them something really simple to measure the strength of their prints.
Stefan, I think you need to have contact with 3D Gustner and talk to him, because he's saying get a load gauge.
That is a load gauge.
To an Arduino.
Yeah, this is exactly what I just described. This is how I'm doing it. I have a load cell, I have an Arduino, but this is, in my opinion, too complicated for, I'd say, 80 or 90% of the people who are interested in testing their own materials. And I want to find something simple. And you have these scales for measuring the weight of your luggage, measuring, I don't know, everything. And there are analog and digital ones, but I didn't find any so far which have this max hold feature.
Yeah, it's and like with the hook that you showed, that's a pretty rigid and strong part compared to this one. And I'm getting like with a stiff PLA, the breaking point is maybe 13 to 16 kilos, depending on if I'm breaking against the printing layer lines or against them. But how many kilos is your device capable of pulling? Because, like you said earlier, you're using Pascals and all those words that I have no idea what mean.
Well, but this is actually one of the things which, so the hook test, the results of the hook tests I'm always giving in kilograms. That everybody has an idea. Everybody has an idea what a kilogram is. Everybody kind of can understand what the size of this hook is. So these hooks usually break between like, let's say 40 to 100 kilograms.
Yeah, so your rig
my rig is capable of loading the parts with around 300 kilograms.
Yeah, okay. So
that's a lot.
It's a pretty rigid design, but it would be amazing if you and Tom could like do a Kickstarter or some form of open source platform to build like a home testing device for people, because
I would really like to make something open source which everybody's able to print out, buy from Amazon or AliExpress just this one scale, and then can do repetitive testing of their materials, because I think there are a lot of people around who are interested in that topic.
Stefan, take a look at the chat.
Yeah. I have read that. Search for. Looking for.
How I do it.
Yeah. How I do it? I'll follow you on Twitter. That you can send me a DM.
Yeah. Yeah, it's a problem with Twitter. You have to be following to get a message through.
That
Well,
happens
otherwise
a
you
lot
would
in these chats.
you would be spammed.
Yeah. Yeah.
Yeah. That's why I always say, Marteinn, contact me on Facebook.
Yeah.
I'm not so often in Twitter. Maybe once a week or so.
Yeah.
All right.
So I have a question. Like I said at the beginning, I should have a chance to have a face-to-face look at the Big Rep printers shortly. I've been in contact. What do you guys want to know? What
Big
kind of things? Yeah. So I think Stefan's aware and Kat is aware of Big Rep. Big Rep is a German-based company. They're based here in Berlin, and they do, as Greg was saying, they do large-scale printers.
And they're massive. They're really massive.
They're
I've
really,
seen them,
yeah. So
at
1
Bornex.
meter, 1 meter
Incredible.
50 size. But their engineering is that they can do very fast printing and higher tolerances. But would there be things that you wanted to ask or want to know? Or
they have one that's 40 deep, 120 wide, and let's say 60 high.
Oh no, that's too small for them.
That's too small.
That would be only a medium wrap.
Yeah,
exactly. We're talking big, as in big. Yeah.
Well, I mean, if it's something like FK1, you know.
No, bigger.
Yeah. I think I saw a picture of a person standing inside.
Yeah. They're massive.
That's too big for me right now.
I would be really interested to know which applications they are aiming towards. Is it prototyping? Is it manufacturing of functional parts? Where do they see their business?
Mm-hmm. Who is their clientele?
Yeah, but I think more industrial. What I saw.
Definitely industrial.
Yeah, you know,
Sure.
Deutsche Bahn is one of their customers. What I saw, I think they're making a project together.
Yeah, the audio industry and the first and second tier suppliers do a lot of iteration and prototyping using FDM printing.
Yeah.
All like the designs for Volkswagen or most of the German car OEMs, the dashboards and things like that. All of that usually for the first and second tier suppliers will start as a prototype being an FDM print.
Well, that's over my head right now.
Okay.
Yeah, I know one guy that is in the automotive industry, and he's working on changing, like takes a Land Cruiser Jeep or similar size car, and they put big tires on it, and we drive it on the Icelandic glaciers and in the snow. But they are starting to look at having 3D printers to do prototyping for various parts. Like when you put a bigger tire on the car, you have to extend the cover for the tire, and I don't know the English word for it, but you know what I mean. So the tire is covered by the shell of the car, and they're doing like 1.5 meter big pieces to cover the entire the curve around the tire. So they're definitely in the automotive industry a use case for those really big printers. It's definitely something that you don't do it on your Prusa or a CR10.
I think that the interesting thing for me is what are the things that they have that they're using in their machines, and what are the things that they see that will, so to speak, trickle down into the hobbyist or the 3D printing community printers. You know, like for as was mentioned earlier in the stream, talking about a sensor as the filament's going in to sensing diameter, things like that. So what did they see from their end being technologies that are used in the industry or industrial machines that will end up on your home machine, your desktop machine?
Yeah, like you would control the feed rate based on actual diameter coming in.
Mm.
Yeah.
That would be interesting. Yeah.
I mean, if they start making smaller printers that are more for the hobbyist, and so that would be interesting to know.
I think they would be above what we could pay. You know, I think the price range is over the roof. I think.
Yeah.
It'll probably still be something like a €2,000 price range for us.
Yeah, more. I guess.
Definitely more.
Yeah, I think there's a big jump between the high-end hobbyist, even though you could maybe have a discussion if a expensive Ultimaker 3 is a hobbyist printer, but that is in the range of $3,000 or $4,000, and then to an industrial that is hundreds of thousands of dollars. It's a huge step between that.
So the cats are coming, huh?
Yeah, I was gonna say, just slightly off topic. Do I need to go get a cat now?
Yes.
What's happening?
Here, I have two around me here.
Yeah, this one is a star of my videos. He's always on my videos and investigating what I'm doing, and I never push him off. I want him to be a part of it, and then sometimes I do a video and he's just sleeping or doing something else, and then I'll get a comment on the video, "Hey, where's the cat?"
Yeah.
And sometimes on the live stream, when Marteinn is showing something that is on his desk, parts or something, all of a sudden you'll see the cat come over there and start looking at the parts too.
Yeah. And, we often stare at the printers print away. We just here together, and if you can see on my T-shirt, this is one of the T-shirts I have. I'm just here for the cat.
I need one of those T-shirts.
Yeah, you can get it at my store.
Oh, okay.
Yeah, I have a Merc store. Yeah. You can see it in the video description.
Send the link, please, here.
I think it would be a problem if you and Kat were at the same maker fair walking around.
We will. So that's where I need to buy one. One.
Yeah, but if Marteinn has that T-shirt on, it's going to be interesting.
Yeah.
I'm just here for the cat, you know.
Yeah.
And
oh no! Now I'm getting it. Oh my god.
So Stefan, this is the point in the stream usually when it gets a little more free and open.
Yeah. We are over the 2-hour mark, and what happens after the 2 hours is it's not it can go
off topic
and
it's strange to be on topic at this point.
Yeah. But I think we had
also already 2 hours over my usually going to bed time.
Really?
So.
Oh my god.
Yeah. What's the time at your location?
Well, 11 p.m.
Yeah. Okay.
So you go to bed that early?
Well, 10 usually.
Oh, okay.
Yeah. Okay. It's
I need a good amount of sleep.
Yeah. Okay.
Stefan is one of those guys that has to get up at 6 o'clock in the morning, huh?
Yes, I have.
Yeah. Okay. I can sleep in tomorrow on the US streams. Those start normally at 2 o'clock in the night. They sometimes go for 3 hours or something, and then I'll be going in the bed at 6 o'clock or something, and I have to sleep in. The Saturday is just off for me on those days.
Well,
I'm a night owl, but that would be definitely, even for me, a little bit too much or too late.
Yeah, it's quite difficult sometimes.
Well, I had a live stream today. I had to take over the 3D Hangout today. Started at 3 o'clock in the afternoon here, Stefan, and that went until 8 o'clock. And then I had to eat fast and then jump on this one. And then tomorrow I have my normal day starting at 3 o'clock in the afternoon. Most of the time it goes until about 11 o'clock at night.
Oh my God.
Yeah. It's a normal 3D print and hangout. I mean, most of the time we talk about 3D printing, but every once in a while it gets completely off topic, because I do have a couple of guys there from America, and America theme number 1, what type of guns do you have?
Oh my God.
I've got this one. Hey, take a look at this one. What do you think about this one? Huh? What type of munition do you use?
Yeah, I saw one of those and I dropped off very quickly because I'm not interested in guns so much.
No.
Yeah. But, it was hard for me to get back on topic.
Yeah.
Yeah, so
yeah.
I don't know if I think I also might be leaving in the next couple of minutes, since I'm getting tired.
Yeah, me too.
Yeah, I think it's been a good session, and we got really good conversation about what methods you're using, and that was my goal, to ask you those questions, and I think it's just a good spot for us to end the stream. So
Stefan, say hi in the chat just in case if anybody is not subscribed to you, so that they can press the 3 magical buttons on the right hand side and say go to channel.
Yeah, and you can see in the video description.
If you leave a comment so that people can
yeah, there too.
Yeah, in the video description is the links, so you can subscribe, and that would be really appreciated. I think for now we will end the stream, and you guys can hang on a little bit. I will stop the broadcast and see you guys later. Maybe if you want to do your outros or say goodbye, you can do that.
Well, I usually say auf Wiedersehen, so yeah, it was really nice. Was really nice hanging out with you guys. Maybe if I had the time to do that again at some point in the future. Friday is just, for me, one of the worst days to do that. No, it was really nice having you. Martin, you also did some really nice tests on your channel. I'm really looking forward that you also improve your setup and maybe also release the plans for the rig that you did, because I think others would also be interested in that. Yeah, to everyone who is still watching, don't forget to leave a like, because it just helps spreading the word. And yeah, thank you everyone for your time.
Bye bye.
Yeah. See you guys.